We are on now, what, 10-2? I decided to keep this up here. I think I did it on your class before. All right. And let's change a couple settings here so I can, right? Projector's not on? All right, well, what I'll do is I will pause. Okay, now I got it all fixed. All right, no more from the peanut gallery. Let's do this. Let's put a circle up here, and we're going to talk about a couple things, a couple angles inside the circle. Some of this beginning stuff is just, it's 360, that's correct. Some of the beginning stuff is just vocab stuff, but it's important because we're going to refer to these things. You're going to have some theorems. I don't think they really, there's some things we'll talk about a little bit later, but a lot of this is vocabulary, and we will do a little bit of math with this. The first thing is a central angle. Let's talk about what a central angle is. First of all, let's draw an angle from the, and look, I'm going to draw it. So many times I draw it straight across, you know, just to get out of that habit. Let's just draw something that looks like that. All right, there's a nice angle. It's not exactly on here. Is that a little bit better? Yeah, there you go. Okay. A little bit too, what do you call it, OCD or whatever? All right, but anyway. So we got a nice angle right here, and we have a central angle. This angle that's formed right there is called the central angle. So this angle right here is called the central angle. Just vocab right now. We will learn quite a bit about, I'll just do the angle symbol. We will learn quite a bit about the central angle, what it's equal to, and just different things like that, and a whole bunch of other angles. You'll be surprised how much there is to know about these circles. But that right there is a central angle. Why is it the central angle? Look at the vertex of that angle. Where is the vertex of that angle located? Okay, it's at the center, right. Thus, what? The central, not center angle, the central angle. Okay, the central angle, and that's that angle right there. Pretty easy. Now this is how, if we labeled this would be circle B, wouldn't it? So if I said, name the central angle, what would you name it? Angle. Yeah, you could name it angle B. That's good. Or you could call it angle ABC as well. Or you could call it CBA. You know the whole deal with that. All right? So that's a central angle. Not that big of a deal. Let's do this. Let's get rid of a few things here. We'll use the same circle. And let's get rid of that. And let's get rid of that little mark right there. All right, let's draw a couple other, just one other one. How about like this? Now, what about all the sum of all the central angles? Let's take a look. We'll call that A. I guess I could have kept that B there. That's C. And let's, oops, it's not C. What would that be? That'd be D. All right, so look. Right here, I've got angle ABC. This angle right here would be angle ABD, and this angle right here would be angle DBC, or CBD, doesn't make any difference. What would the sum of all the central angles be?
360.
It'd be 360, that's right, okay? Because if you added this, and then you added this, and then you added this one right here, guess what you have? Whole circle. How many degrees in a whole entire circle? 360 degrees. So the sum of all the central angles is 360 degrees. Pretty simple. Agreed? All right, let's pause this. All right, we're starting back up again. We've got a circle here. Let's call this angle, the central angle, 130 degrees. Oh, that doesn't look very to scale, but that's all right. We'll say that's a right angle, and we'll call this X. Now, with what we just did, this shouldn't be too hard at all. And you wanted to solve for X. That's what you're going to do. Pretty simple. What did we say all three of them add up to be? 360. So what do? We go 360 what? Let's just do the math right now. 360 minus these two. Yeah, can you do 90 and 130 in your head? 220. All right, so 220, and what does that equal to? 140. All right, so X, okay, we've got the X right here. So X is equal to 140. So that's a sampling of what you could do with this kind of thing. We okay with that? All right, let's pause. All right, we have another situation right here, and we have a circle. We've got an angle drawn. Now, we know that this is a central angle, but there's also something else. Let's change color of this just so it stands out a little bit more. We also have, see where it cuts off? We say that this angle hits right here, and it also hits right here. and it cuts off this part of the circle. Do you see it? Well, they have a name for that part of the circle. Now I'm going to try to trace around it, but it takes a sure hand, and I really don't have much of a sure hand on this thing. Well, that's not half bad right there. That's better than what I've done in the past. Thank you so much. So anyway, we call this thing an arc. All right? So around the circle. So basically, it's a portion of a circle. All right? So if I like chop off a piece of a circle, we call that piece, we call it an arc. All right? So we've got an angle, we have an arc. Here's something else. We measured angles in what? What do we use to measure angles? Degrees. Let's just make something up. Let's say this is 150 degrees. All right? So let's say it's 150 degrees. Arcs are also measured in something, okay? They're also measured in degrees. We're going to talk about, we're not talking about like how long the arc is. We're just talking about like kind of how far around the circle it goes. Well, like angle-wise, how much it goes around, okay? So, okay. So the arc is measured in degrees as well. Now what's cool about this is the arc is equal to its central angle. So if you know the central angle is 150 degrees, then this arc right here is going to also be equal to 150 degrees because arcs are measured in degrees. Yes?
So would the two sides, the two vertices at the end of the arc, would they...
These 2 points, right? These end points, you mean?
Would they be both...
Yeah, let's name this.
So would A and B both be...
Well, they're just points on the circle.
Like 75 degrees?
No, they're just points. A is just a point. Okay, so from here to here would be 150 degrees. Now watch, what if I went all the way around? What if I went from B all the way around to B? How many degrees would that be? That'd be 360. So this is just a portion of the distance around the circle, or the distance around the circle. You with me on that?
Yeah.
Okay, so but we do measure it in degrees. So that's an arc, and it's 150 degrees. Now let me talk about this. We have several different types of arcs. We have a minor arc, which that is not. We have a major arc. You'd think we'd have a major one if we had a minor one, wouldn't you? All right, and then we have a semicircle.
Ooh, so it's like that would be a minor arc because there's just like minor geometry.
All right. Okay, so let's take a look at this. Let me pause. Zoom. Okay, Tiffany brought up a point, and I messed up. For some reason, I was thinking 90, but it's 180. If you went all the way across, in fact, let's do this. Let's take this little arc right here, or not arc, but that little segment, and we'll make it go all the way across to there. All right, so we got a diameter. From here all the way to right here would be how many degrees? 180. Okay, so anytime you have an arc that's less than 180 degrees, so a minor arc would be, would we say, less than 180 degrees. So a minor arc is anything less than half a circle, okay? So it's less than 180 degrees. A major arc, now watch this. Let's go to a different color. If I, what do you want, this nice blue right here? Now this is going to be a little tougher because, anyway, this is going to be, actually, let's make this a little thicker, right? Okay. I know.
Oh,
I'm not going back. I don't care. Oh my!
you just betrayed your country.
I'm sorry. I'm sorry. Okay, the blue one right here. Now watch. If the red one is 150, what is the blue one? How would you figure it out?
It'd be 360. No, wait, no, never mind.
It'd be 360 what?
Oh, well,
Minus 150, correct? So that's a 0, that's a 1, that's a 2. So it's 210 degrees. All right. Now, what do you think? We've got major arc is less than 90 degrees, or less than 180 degrees, I'm sorry. Then a major arc, what do you think that is?
it'd be more
It's
than...
going to be more than, greater than 180 degrees. All right. Now, what do you think a semicircle? If a minor is less than, a major is greater than, what do you think a semicircle is?
Equal.
It's equal to, how about equal to 180 degrees? So let's put some other, let's go back to red again to keep these consistent. So what do we got now? We got D we need, right? And let's put a point, that's fine. We'll put the D right there. Now watch, a minor arc. If I talk about a minor arc, we're only using 2 letters. You guys are paying attention, right? Because this is important. A minor arc, you're only using 2 letters, A, B. And this is how we designate an arc. We put a little symbol like that. All right, it's kind of like a half circle kind of thing over top of it. Yeah, I didn't do it very accurately, but it's Probably more like that. Okay, that looks a little bit better, doesn't it? Okay, so that's what the symbol for an arc is. All right. So a major arc, actually a minor arc, it could be AB, or you could write it. How else do you think? BA. All right. I know. We can actually go to 11 minutes, but let's stop. We'll stop and we'll move. We'll start again on the next one.